Good day, viewers. Welcome to Young Man's Academy. Today, we will continue our learning on latitude and longitude. As you can see on the board, we have a question on board. The question says, A and B are two places on the Earth's surface on the same meridian. B has latitude 20 degrees north and A is a point north of B, such that the distance AB measured along the meridian is 800 kilometers. Calculate the latitude of A correct to the nearest degree. We are to take pi as 22/7 and the radius of the Earth, that's R, as 6,400 kilometers. Quickly, before I go into solving this question is based on distance along a great circle. While calculating distance along a great circle, we already know that the shortest distance along a great circle is the distance of the arc length, the distance of the arc length between 2 points, say A and B, that is being related to the great circle. That is what I'm saying is, if we have our diagram to be like this, we know that our Earth is a sphere. Suppose we have this meridian, we have this, we have our equator this way, we have the polar axis. Let's say this is a point A. If this is a point A and this is a point B on the same meridian. Now the distance along the great circle, where A and B are points on the surface of the Earth, is being created by the arc length, and then if we take A and B as those two distances, we say that our AB, the distance AB, which is the arc length or the distance, is equal to theta over 360 times 2 pi r. So whenever we are calculating two distances on the Earth's surface, our distance between those 2 points AB is taken as theta over 360 times 2 pi r. Okay, so going back to this question, now we have to find distance between AB, two places on the Earth's surface on the same meridian. Good, just like this, they are on the same meridian. B has latitude 20 degrees north. We know that this edge here, this is north, this is south, this is east, this is 0 degree, this is west. We know here is 90 degrees south. So we are told that B has latitude 20 degrees north. So I will create a kind of small circle here, a small circle. So if I have this small circle, just like this, so this is point, let me say this is point, this point. So it said B has latitude 20 degrees north. If this is point B, I can name here B, 20 degrees north. And A is a point north of B. A is a point north of B. So that's why I have to label this B. A is a point north of B, so still on the same meridian. So let's here be point A. Let's put here to be a point A. So on the same meridian, we have that A is a point north of B, such that distance AB is measured along the meridian. And the distance is 800 kilometers. We are told that the distance between A and B is 800 kilometers. Okay, AB is measured along the meridian is 800 kilometers. Calculate the latitude of A correct to the nearest degree. So we have to calculate the latitude of A. We already know the latitude of B to be 20 degrees north. We know that to do this, we will always refer to our equator, to our great circle. So distance covered between the 2 points. So is always being traced to the equator, to the center here. So A also, I can create a point like this, something at this point A. That will come this way, create something like this point A. Then we look at this from this diagram. So I want to know the distance between A and B. The distance between A and B, the arc length, which is A, B. So this from here we can see that this is what we have. We have the diagram such as this, something like this, something like this, something like this. So we have this to be point A, this to be B. Here will be theta. Theta is our angular difference. So, okay, we can bring out this diagram from this shape here, from this sphere. Now, to get the distance between these, to get the latitude of A, we know that AB is given to us. AB is the distance, so the distance, the arc length, the distance here is 800 kilometers. So quickly to do that, I can simply write here that AB, which is theta over 360 times 2 pi r. AB is 800, so we have 800 kilometers. Theta over 360 by 2 times 22 over 7 by, so I have to work off this. 2 times 22 over 7 times 6,400 kilometers. That's the radius of the Earth. Here we have it to be 800 by 360 by 7, which is equal to theta by 44 by 6,400. Okay, so from here we take that theta is equal to 800 by 360 by 7, and that's divided by 44 by 6,400. So doing this, we get theta, our angular difference, to be, I'll just rub this off, approximately we have theta to be 7 degrees, because we are to take this to the nearest degree. If we punch this in our calculator, we have 6.778 degrees, something like that. So if we approximate to the nearest degree, we have theta, angular difference, to be 7 degrees. But we are asked to find the latitude of A, and recall that your angular difference, theta angular difference, is latitude A. So it will either be minus latitude B or plus latitude B, but you have to get that from the question. It is stated that A and B are two places on the Earth's surface on the same meridian. So A and B are on the same meridian. So when they are on the same meridian, and we can see it's a latitude 20 degrees north, means that's the B, A will also be latitude also. So it means that since they are going in the same direction, same meridian, it is latitude A minus latitude B. So latitude A minus latitude B. When they are in different direction, going in different direction or different meridian, we take the addition. So here we have that theta is latitude, and theta is going to be 7 degrees. Latitude A is what we are looking for. Latitude A, and latitude B is 20 degree north. So from here we can see that latitude A, latitude A is equal to 27 degree, so it has to be 27 degree north as well. So because this is latitude A can just be represented as a theta degree n, so we can see that is a theta degree n, so which implies that our latitude A is 27 degree north. So this is the solution to this question. So while calculating distance along a great circle, first thing is to always bring out our sphere, the x as a sphere, draw the shape out, then you find out those 2 points on what meridian they are, and then know if they are in the same direction or not. Bring out the shape, the diagram, and know if you are given the distance, so you have to look for the distance, or you have to look for the latitude or the longitude of that. So thank you.